In this video, we will show you how putting electrodes around the heart creates 12 unique points of view of heart conduction, which we call a 12-lead EKG. Let's start with how electrodes work. Because the heart sits deep in the chest, placing electrodes directly into the heart tends to be unpopular with patients. We need a way to indirectly measure heart depolarization. Because the body is full of water that contains salt, your body fluids are able to conduct electricity. This means that every time the heart depolarizes, it generates an electric field that ripples through the body fluids. The skin electrodes have a conductive gel that seeps into pores and sweat glands on the skin. This gives the electrode contact with the inner body fluids. These electric fields travel in the same direction as their associated depolarization wave and are of similar size. We usually draw them as arrows called vectors. Vectors have direction and magnitude. But you already knew that, didn't you? The direction of the arrow represents which direction the depolarization wave is moving. The size of the arrow represents its magnitude. This is determined by the number of cells that are being depolarized. For example, the thick, muscular left ventricle has lots of cells. When it depolarizes, it creates an electric field with a huge magnitude. The thinner right ventricle, on the other hand, has a lot less muscle mass, so it makes smaller depolarization waves. These depolarizations appear as deflections on our EKG. The bigger the vector, the bigger the deflection. Well, usually. Deflection size also depends on how directly a vector points towards an electrode. I'll show you what I mean. Here we have a red electrode, a blue electrode, and a yellow electrode. If a depolarization moves directly towards the red electrode, then it will record the largest deflection. Let's watch that again from the blue electrode's point of view. Notice that the arrow is pointing at a 45-degree angle to it. Because the depolarization vector doesn't face it directly, the blue electrode will record a smaller deflection. The yellow electrode is at a 90-degree angle to the vector, and it hardly detects anything at all. The vector isn't pointing towards it, so the electrode doesn't see it. Electrodes are best at measuring waves that come directly at them. Because the angle is so important, in a 12-lead EKG, we place electrodes all around the heart. Each electrode has a slightly different angle to the heart and will create a different EKG tracing based on its own point of view. To understand how that works, we need to talk about something called a lead. A lead is an electrode or set of electrodes that's used to make an EKG graph. Let's look at some examples. We have 6 electrodes on the chest that make 6 different leads. Notice that the EKG changes slightly in each one. This is because each lead is measuring depolarization from a different angle. The electrodes on the limbs create 6 more leads. This includes the most common ones like lead 1, lead 2, and lead 3. The limb electrodes can be placed anywhere along the limbs as long as they match. So wrists and ankles, elbows and knees, shoulders and hips. They can even be placed on the torso. Each lead is at a different angle and records a different EKG tracing. Okay, at this point, you might be wondering why we have so many leads. Why would we ever want so many different EKG graphs? Think about it this way. Imagine you want to buy a used car online. Because you're not there to physically inspect the car yourself, you have to rely on pictures. But what if the seller only gave you one picture of the car? The car looks fine in this picture, but you can't see the entire vehicle. If you're a cautious buyer, you might ask for more pictures from other angles. With multiple pictures taken from different points of view, we get a better idea of what condition the car is in. Ooh! Wow, look at that bumper. There's quite a bit of damage there we couldn't see from the other angles. Each lead on our EKG is like a different picture of the car. If we only look at the car or the heart from one angle, we don't get the full picture. However, if we look from multiple angles, we might notice damage we couldn't see before. The 12 leads on our EKG give us a more complete representation of heart conduction.